Namaskar. Welcome to the channel Anka Anand Aharan, that is extracting happiness from the teaching learning process of mathematics. Today we will discuss about one of the important aspect of linear algebra, that is elementary operations, which will be giving us elementary matrices. What do we mean by elementary matrices? We will learn it. Before knowing it, we should know what is an identity matrix. A square matrix with each diagonal element as 1 and non-diagonal element as 0 is said to be an identity matrix. When identity matrix is multiplied to any matrix, the matrix remains unchanged. That is, A into I is equal to I into A is equal to A. So now, what do we mean by elementary operations? There are two types of elementary operations. Row operations, elementary row operations or and elementary column operations. Row operations, there are three types of row operations. Ri plus k rj stored in Ri. Its meaning is k times of jth row contents are added to Ri. That is, the resultant will be stored in Ri. It is first operation. Second operation is interchange of ith row with jth row. And third is ith row is replaced by k times of jth row. These are the three operations. Similarly, the corresponding column operations are also there. Elementary matrix is a matrix which is obtained from identity matrix after one elementary operation operated on it. For example, if I consider the identity matrix, now what I am doing? 3 times of row 3 I am adding to row 2 and the resultant I am storing in row 2. Then this operation is nothing but our R2 plus 3R3 stored in R2. Here observe some specific observations. Now here it is my identity matrix. The corresponding elementary matrix I am interested to write. What I will do? This 2 position, 3 position element I will collect, which is here. I will replace it by this 3 position element, which is written here. Now I will replace it to get this. So I got my corresponding elementary matrix. How to get it? All of you got it? What I have done? This R2 plus 3R3 stored in R2. This R2, 2 position, 3 position, 2, 3 position element, whatever is there in the identity, that 0 I am replacing by this value, that is plus 3. So here it is 3. I got my identity matrix. Now you tell me, let us consider another matrix. For example, I want to write down R2 plus 5R1 stored in R2. Now how should I write? I will write every element other than 2, 1 position. This is 2, this is 1, 2, 1 position. I will write all other elements other than 2, 1 position. At 2, 1 position, I will write 5. So, very quickly we got our corresponding elementary matrix. Now, in this operation, I got my elementary matrix. What I have done? On identity matrix, I applied one elementary row operation to get my new matrix, which is an elementary matrix. This elementary matrix, when multiplied to any given matrix from left side, row operations takes place. If it is multiplied from right side, then column operations takes place. And here one can observe that I have added 5 times of row 1. So row 2 is changed by 5 times of row 1 plus row 2. So from here, if I want to get row 2, what again I have to do? I have to subtract 5 times of row 1. So what I will get here? here plus symbol, its inverse operation is minus symbol. If minus might be there here, then I might have done. So here whatever sign is there, its sign will be replaced by its opposite sign. If it is plus, I will make minus. If it is minus, I will make plus. That is reverse operation. Similarly, it is a matrix. As it is a matrix and its determinant is 1, it is a non-singular matrix whose inverse exists. And here, to get the inverse, I will observe this element. Whatever sign it has, I will change its sign. Okay, so what I will get? Inverse matrix. Whatever 5 is there, its inverse is minus 5. Everything remains same, the matrix only this sign will change, or inverse operation. So any matrix, any elementary matrix, its inverse can be very comfortably obtained. Now let us go to another operation, row interchange operation. Here what happens? R1 is interchanged with R3. So this is my R1 of identity matrix, and this is my R1 of identity matrix, and this is my R3 of identity matrix. If we interchange, we are getting a new matrix. Observe here, R3 written here, R1 written here. This is my elementary matrix. Very comfortably I got my elementary matrix by interchanging. Now from this matrix F, how to get my original matrix I, or identity matrix? The same operations I have to repeat. That is, I have to interchange row 1 with row 3. So the matrix, this F inverse is F itself. Now let us go to the third variety. So here what happens? Any row is multiplied with by a scalar. That means a row is replaced by a scalar multiple times of itself. So here for example what I have done, here the first row is multiplied with 3. So it is replaced. Now let us go for what is the role of elementary matrices. If elementary matrix is multiplied to any given matrix from left, then the corresponding operation that took place while obtaining that elementary matrix takes place in A. That is, if here how I have got E by R2 plus 3 R3 stored in R2. With this operation, I got my E. Now, when E is multiplied from left on A, so what I will get? Dekho, please observe this rows and these two rows. First and third row remain unchanged. Only change take place in the second row. How much should I write? 2 times of third row, I should add it to second row. So 2 times of third row means 2 nice, 3 times. 3 times it is here. Here it is 3, na? Here it is 3. So 3 times of this row, I will add it with this row. How much should I get? 6 plus 3, 9. Similarly, 3 plus 1, 3 into 3 plus 1, that is 10. 3 into 1 plus 2, that is 5. So I got my new matrix, only this row changed. So here the resultant is having a change in the second row. Similarly, when I multiply F with A, how I got F? From identity matrix, how I got my F? I got my F by interchanging the first row with third row. Now, same thing will take place in A. That means observe here, the first row is here, third row, and third row is here, first row. Okay, now the question is, what do we mean by sorry. Similarly, how to get my third type of change? or elementary matrix. Here, observe among the diagonal elements, one diagonal element 1 is replaced by 3. So, here the first row is multiplied with 3. So, to get this matrix, what I have done? I have multiplied the first row with 3. First row of identity matrix, I have multiplied with 3 to get G. Now, when G is multiplied from left, what I will get? First row, observe, this is my first row. It is multiplied with 3. So, it is 3, 6, 9. Rest all remains same. Okay. Now, here, how I have got G? By multiplying its first row by 3 with 3. Now, from G, how I will get the identity matrix? If I divide my first row by 3, I will get identity matrix. So that is my inverse. What is G inverse? G inverse is 1 by 3, 0, 0. What is G inverse? It is 1 by 3, 0, 0, 0, 1, 0, 0, 0, 1. What is F inverse? F inverse is F itself. And what is E inverse? E inverse is 1, 0, 0, 0, 1 minus 3, 0, 0. So with this, we will conclude the video today, and next class we will discuss further aspects and applications of elementary matrix. Thank you for your patience listening.